Welcome to part 2 of the CCREF's, or Composting Council Research and Education Foundation's Compost Sampling Guidance video series. The CCREF, along with the USDA, has developed methods through the development of the test method for the examination of composting and compost, or TMECC, publications.
The following items will be covered over the course of this video. Additional sampling techniques for heterogeneous materials. Guidance for compost analytical parameters requiring additional considerations.
Please be sure to watch the entire video before developing a sampling plan and initiating the sampling process. Additional sampling guidance is available from the CCREF.
Variability in feedstock, physical, and chemical quality, and variability in compost blending techniques has the potential to result in variability during composting and in your final product. Area sampling provides a method of quantifying variability, which can provide guidance for making operational changes to address the variability. For instance, materials with higher moisture content or higher nitrogen content may need some additional bulking agent or may need additional composting curing time. In this case, instead of randomizing subsample collection locations, pick spots within the stockpile or windrow that you have reason to believe may have different characteristics. Our suggestion is that within those separate locations, collect 4 1-quart samples of compost from 4 closely spaced spots within the chosen locations. Make a composite sample for each of the locations by blending the 4 subsamples with a hand trowel in a sampling bucket. Label the composite samples from each location with sample IDs reflective of the locations, for example, wet, west, or deep.
In large windrows that are turned in frequently, or in static piles, stratification can occur within the composting mass. For sampling such piles, either for making composite samples or for sampling to determine variability between the strata, using composting equipment such as front-end loaders or skid steers to provide access to cross-sections of the piles makes collection of the samples easier. When collecting subsamples for a composite sample representative of the whole pile, use 3 depths within the cross-section, with the closest one to the surface always being at least 8 inches into the pile. For instance, if your cross-section is 8 feet, your first subsample could be at 8 inches from the surface, the second subsample could be at 3 feet from the surface, and the third subsample could be 2 feet from the bottom of the pile. When collecting subsamples for area sampling, use the same method just described, but collect 4 1-quart subsamples at each depth chosen for sampling, and composite these 4 to provide the sample that will be representative of the material at that location and depth within the pile. In video 1 of this series, sampling instructions were provided for common composting parameters, such as nutrient content, pH, organic matter, moisture, and maturity. In some cases, additional parameters are required for analysis, which require additional considerations in the sampling, preservation, and shipping process. The next portion of this video will discuss some of those considerations.
When sampling for the pathogen content of compost, such as fecal coliform levels, special care must be taken in the preservation of the sample. Compost by nature is biologically active, and when analyzing for respirometry and pathogen content, it is important to slow down that biological activity immediately following sampling in order to provide accurate, defensible results. The collection of subsamples to make a composite sample for this analysis is similar to the process described in video 1. As soon as the composite sample is homogenized, place the subsample immediately on ice packs and in a cooler in order to minimize biological activity. You can refrigerate the sample, but do not freeze the sample, as that can impact regulatory requirements for pathogen analysis. Hold time for fecal coliform in the TMECC sampling guidance is 48 hours. Prior to collecting the sample, call the lab to let them know when they will be receiving the sample. Ship via overnight delivery and do not ship on a Friday. The lab may not be able to receive the sample on a weekend.
When sampling for trace metals such as arsenic, copper, lead, or zinc, Use the same method for collecting subsamples detailed in video 1 of this series. The key with trace metal testing is to avoid having the compost sample come into contact with equipment or surfaces that may contribute additional metals. Plastic hand trowels and buckets, along with blending on a plastic tarp, should avoid introducing additional metals. Stainless steel trowels, spoons, and bowls could also be used and are better to use if also analyzing the compost for parameters for which plastic equipment may confound the results. It should be noted that galvanized metal equipment should not be used as it can introduce additional zinc. If using a shovel to dig to the depth of the subsample, scrape away the area that has contacted the shovel blade prior to collecting the subsample with a hand trowel.
In some cases, the analysis of organic compounds may be required for your compost. Analysis of organic compounds can include residual pesticides, volatile fatty acids, semi-volatile organic compounds, and other organic compounds present in very low concentrations in compost. The same subsampling procedures outlined in video 1 should be followed by obtaining a composite sample. However, in the case of organic compounds, sanitized stainless steel equipment should always be used to collect the sample. Plastics have the potential to add additional organic compounds to the sample that may skew results. Additionally, some organic compounds, particularly volatile fatty acids, may volatilize during homogenization of the subsamples into the final composite sample. For volatile fatty acids and other volatile organic compound analysis, blending the subsamples should be less vigorous, making an effort to not aerate the samples excessively. As with pathogens, due to the dynamic nature of organic compounds in compost, the holding time for the sample is often shorter than for inorganic parameters. For some organic compounds, the holding time is as short as 7 days. There are different recommendations for the proper containers to use for different classes of organic compounds. However, for most organic compounds for which compost may be analyzed, a sterilized amber jar with a Teflon lid should suffice.
A natural consequence of a larger percentage of the organic waste in the solid waste stream being captured for recycling is that some compost feedstocks contain a greater amount of physical contaminants, such as plastics and other inert materials. TMECC currently has 2 analytical methods for quantifying the percentage of inerts contained in finished compost. 0.3.08, the most commonly used method, and 0.3.06, a wet sieving method. Approximately 1 gallon of compost is typically requested by the labs to perform either of these analyses. CCREF has received feedback from some labs that composts and feedstocks with a higher degree of physical contamination require a greater amount of sample for analysis. It is our recommendation that if levels of inerts in compost or feedstocks sampled for analysis are higher than typical, that the sampler send 3 to 4 gallons of finished compost for analysis. Collecting subsamples for making a composite sample should follow the same protocol detailed in video 1, with a strong emphasis on randomizing sample collection points to eliminate the potential of sampler bias. However, for material with a higher level of physical contaminants, the size of each subsample should be increased to provide for a final composite sample that will contain 3 to 4 gallons.
As a brief reminder of compost sampling issues often encountered by compost analytical labs, elaborated in part 1 of this video series, please remember the following. Cool samples to between 0 and 4 degrees Celsius or 32 to 39 degrees Fahrenheit prior to shipping. Use blue ice packs instead of water-based ice. Confirm the sample size required by the lab for analysis prior to making the composite sample. Fill out the chain of custody or COC completely. Ship overnight and confirm with the lab that someone will be available to receive the delivery on the day it is scheduled to arrive.
Thank you for watching part 2 of CCREF's video series on sampling compost in accordance with TMECC method 02.01. Our goal in this video series is to provide you with sampling instructions that will help to minimize potential sampling and analytical errors in support of developing accurate information about the quality and the value of your compost. Please contact CCREF for additional compost sampling information and to provide feedback on this video.